Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be making the calculations for the AC values from the Chapter 15 Math Handout, problem number 20. So here we see a combination circuit. It is a basic combination circuit. It is not a random unknown. So our first equation or value that we want to find is RT. So we see here that R1 and R2 are in parallel with one another. We also can determine that they are in parallel with the voltage source because there is only one pathway for current to flow through. Leaving the voltage source here, you see that there's only one pathway for current to flow through R3. This tells us that R3 is in series with the voltage source. Once the current continues, it has an opportunity to split, part of it going through R1, part of it going through R2. So this tells us that R1 and R2 are in parallel with the voltage source because there is more than one pathway for current to flow through. If there's only one pathway for current, it's series. If there's more than one pathway, it is parallel. So we understand that R1 and R2 are in parallel with one another. So I'm going to use the reciprocal formula to combine the values of R1 and R2. For a new value of 50 ohms by combining R1 and R2 using the reciprocal formula. R3, that value, I just brought it straight over without changing it. 120 ohms, just brought it straight over. So now I have 50 ohms in series with 120 ohms. And we just add resistances together in series, so this gives us 50 plus 120, which would be an RT of 170 ohms. That was our first step in finding our RMS values. Alright, next we can find IT using Ohm's law. If we take VT divided by RT, this gives us our IT. Since R3 is on the main branch, I3, which corresponds to the amount of current that flows through R3, will also be 1 amp. Because all of the current that flows in the circuit must flow through the main branch. Remember, there's only one pathway for current to flow through. So this 1 amp of current that we just calculated by dividing VT by RT is going to be the same for I3, 1 amp, because I3 is on the main branch. Now we can find V3 by taking I3 times R3. This will give us the value of V3, 120 volts. Now, as I said, R1 and R2 are in parallel, so that tells us that V1 and V2 will be the same because voltage stays the same in parallel. But it can't receive the full 170 volts because we dropped 120 volts at our R3 right here. So we take the 120, we subtract it from the 170, and that tells us that the V1 and the V2 will both be 50 volts. It is the same voltage, it's just not the full 170. We have to take the 120 out of it first. And here is a simple equation to express that. V1 equals V2, which equals the VT minus the V3. Alright, now we can use Ohm's law to find I1, which would be equal to V1 divided by R1, 500 milliamps. Now we can find I2 by dividing V2 divided by R2, and this gives us our I2. So we've completed all of our steps here. So now it's just a matter of finding our AC values. Well, resistance is unaffected by AC, so it's just 170 ohms. RT is RT. Next is IT peak. Here we have an IT value of 1 amp. So looking for peak, we take that 1 amp RMS value here times 1.414, and that gives us our IT peak value of 1.41 amps. Next, we're looking for VT peak to peak. The first step is we want to take this VT RMS right here of 170 volts, and we want to find the peak. So we take the 170 times 1.414. That would give us our peak value. And then we take this number times 2, and that gives us our peak to peak value. So the first thing we did was find RT by combining R1 and R2 using our reciprocal formula. That gave us 50 volts. We took the 50 and the 120, we got our 170. The next thing we did was we found IT by dividing the VT by RT. That gave us our IT of 1 amp. And we understood that IT and I3 would be the same because I3 is on the main branch right here. So then we had I3 and R3. We could find V3. Our next step was to find V1 and V2 by subtracting V3 from VT, and that gave us the value of both V1 and V2. Then we could find I1 using Ohm's law, V1 divided by R1. We could find I2 using Ohm's law, V2 divided by R2, and then we just plugged in the appropriate AC formula to find our AC value.